This project was initiated in response to the first wave of COVID-19 when there were shortages of PPE. And a lot of makers were trying to help medical professionals by making respirators and face shields and that kind of thing. The goal of this project was to look through the various devices that people had come up with, to test the most promising ones, and then to make improvements. We tried multiple different designs, and we eventually came across a 3D printed mask frame.
Il y a beaucoup d'études, dont les études de notre laboratoire, qui ont montré que l'effet prépondérant dans l'efficacité des masques de procédure, c'est les fuites. Donc les travaux de Nathalie ont permis de pouvoir réduire l'effet de ces fuites et donc elle a augmenté l'efficacité des masques qu'on utilise.
So basically the mask frames are printed flat, which for 3D printing is a much faster process. And then what we do is you take the flat frame and you heat it up and you put it on your face and you mold it to your face. The idea is that it fits over the surgical mask, and so that it prevents any gaps between the mask and the face. Now this is the original model that was designed by Xuan on Thingiverse. The problem with this model is it has a rigid jawline here. So when anybody's talking, it pulls the mask into your nose. We redesigned the frame so that the bottom part is just elastic. And that way when somebody talks, it stretches with the movement of the jaw, so that it doesn't cut into the nose at the top. Now, with 3D printing, it is a very slow process. So we want to make sure that there's as little 3D printing as possible, as necessary. We designed a third model where not only the bottom was made of elastic, but also the sides. And the only part that is rigid is this top part here. And that's just because our face here is concave. So you can't rely on elastic here, because if you relied on elastic, it would just go straight across. But with 3D printing, we could create this curve to prevent air from escaping or entering the mask. This design is simple, it's elegant, it's very quick to print. Other designs are 14 hours to print, require silicone, require 3D scanning, and yet this one, it's just a 15-minute print, and it seems to work very, very well.
C'est un travail qui a été multidisciplinaire, donc il a permis de pouvoir faire travailler des chercheurs en design, des chercheurs en sciences des aérosols, des chercheurs en textile. Donc chacun a apporté sa contribution pour pouvoir faire quelque chose qui est nouveau. Donc les frame ajusteurs proposés par Nathalie a permis de faire travailler toutes ces personnes-là sur un même sujet durant la pandémie.
Ce projet fait partie des projets qu'on a réalisés lors du Covid-19 à l'Université Concordia, au laboratoire de filtration. Ça a été financé par MITAC avec le support de l'IRSST, sous la direction de moi-même et deux professeurs de l'Université Concordia, Barbara Lynn et Alois Davidson.